Okay, I got a Raspberry Pi B revision 2, and I'm just going to demonstrate GPIO and 4 7-segment LEDs here. And what it is, just what's going on is it's just switching between them. Okay, so I got these 4 guys here switching between. Can't get them together here. Okay, so I got 7 GPIOs switching to 7 segments per LED, and then I got 4 GPIOs switching transistors here on. So the 4 is just going through the 4 transistors, which are switching on the 4 7-segment LEDs. So right now this transistor is on, and now this transistor is on, switching this LED, 7-segment LED, and then this transistor is on right now and it's switching to 7-segment LEDs. And going this way, these wires here, it's switching the different, it's powering the different LEDs. So you got 2 ways. You got the it's switching the entire, you got the transistors switching on the entire module. Then you got the 7 GPIOs that's powering the 7 segments here. So in parallel, the 7 GPIOs are connected to all 4 of them in parallel. So GPIO 1 is connecting to segment 1 here, segment 1 here, segment 1 here, segment 1 here. GPIO 2 is powering each of the segments, the second segment, third segment, up to 7 segments. Okay. And I just got one of these little connectors here on eBay. You can find them on eBay. It's a 26-pin GPIO, 26-pin header. Okay. Alright, I'm just gonna show you on paper how this works. So it's going through the LEDs. It's the LED 7-segment LED is a common cathode type. So it's common cathode. And so on. Okay, so LED, and what I have is actually that to and then another one. I have 4 of them here. Each one of them is exactly the same way, and they're actually in parallel. and so on and so forth. You get the drill. Yeah, you get the drill. And what I have here is transistor here, a NPN transistor, and so that's going to the ground, which is negative, and the collector, emitter collector, going to the pin, one of the pins in the 7-segment LED here, and the base of the transistor here goes to yet another one of the GPIOs. Okay, so I got 7 of these. Got 1, 2, 3, up to 7 of these, and this is another one. So it switches on the first one. So let's say you want a number, let's say 1. It'll switch on 2 digits plus the transistor, so that it'll get the you have the first module. And I actually forgot one thing: the resistor here, which is a 470 ohm resistor here. And same story here. $470. Kilo ohms. So 0.7 kilo ohms, which is 470 ohms, 4,700 ohms. And same thing here. Transistor. And same here, transistor. So first, so the switches, so it'll switch on, let's say the segments here to form, let's say 7. It'll switch on 3 LEDs here, plus it'll switch on this 1 transistor to get this digit, then to get, let's say 3 on here. Then it'll switch off this guy and switch on this guy here, this transistor. Then it'll switch on these LEDs here. So 1, 2, 3, 4, 5, and then it'll go to this one, and let's say this one's 0. It'll switch on these segments here, and it'll switch on this transistor, and then this one. So that's actually what's going on inside. Okay. Let's see. one of the things I want to show you is how to tell these guys here. How to tell the segments, and also how to tell if it's a common anode or common cathode. So let's do that. What you need is a meter. So I got it on. I fell asleep. No one else. It's got the diode checker. Got the little diode checker because the LED is a diode. Okay. It's actually pretty easy. And so let's say you got a 7-segment LED and you have no idea what it is. So just start playing around with the pins. This is sending out a very low current, so you're not going to damage the LED. You can't damage it again. You can't damage it, so don't worry about it. See, it's lit. The lights up. Actually, let me switch off the lights. It's a little too dark. But just for demonstration purposes, you just guess. Oh look, see, lights up. Okay, so turn back the lights on. So first, let's find the common point here, the ground. So I'm guessing that either this one or this one's the ground. But since it's lighting up 2 LEDs, you can see it's two points are lit. See, so my guess is that this is the common cathode, common anode here. So first we found that it's a common anode, and this is the ground. So I found that this is the ground, and it's a common anode. So let's go further, and we find that for sure that is the common pin here. Okay, so we discovered that it is a common anode, and this is the ground. And so if you want to just scout around and find all the digits. So we already found 1, 2 digits, 3, 4 digits. Okay, so that's how you find the digits, and that you found that it is a common anode. Same with the LED here, the red LED here. You just guess. Just lit. So it just lit and the camera just tilted. Okay, so just found, again, it's a common anode because more than one lit, and I didn't move the red lead here. Okay. Okay, and you can just scout around and look for the digits. Okay, so this is the ground right here. This pin here would be the ground. and yours is going to be different. So whatever LED, whatever 7-segment LED you find, it's going to be different. Okay, you have to guess. You're going to have to guess each time, unless it tells you. Let's go like Radio Shack or something, and it tells you like here. So this is one from Radio Shack, and it's clearly documented. But let's say you didn't have that. Okay, like what I have here. How can you tell if it's a common anode or a common cathode? So what I'm going to do is I'm just going to pull out and show it. Well, it will be the same thing. It will be the same. But just to show you, I'm just going to pull it out. Okay, so I'm just going to pull that out. And so let's say we don't know what this is. So I'm just going to pretend that I don't know what this one is. Oh, see, we already found something. Something lit. Oh, another one lit. Okay, so this one's a common cathode. More than one digit lit, and the negative pin, the negative probe here, connected to this pin here, while the red probe touches different pins and it lights up different segments. This black one here didn't move, so it's a common cathode, and it's the ground is negative. Ground is here, and it's negative ground. So it's a common cathode. Okay, black probe touching the this ground here, and the red one moving around. So that's what it is. One other thing. Reason for this switching is like when you look at your clock, your clock at any given point only. When you look at your clock, you'll see that if you look like across like that, you're going to see that only one segment is lit at any given time, and the reason is to save power. Like here. If I try to power all 7 segments on all 4 modules here, so let's say it will be 7, 14 will be like 28. So if I light up all 28 segments here, it won't be able to. I probably could, but it would take up a lot of power on the GPIO, and the Raspberry Pi GPIO was not meant to power anything. It was only meant for switching. It was only meant to send out a signal. So I shouldn't be powering like all 4 of them together. So at any given point, it's only switching on one just to save power. And the ideal thing to do is to switch them on really fast, like this one, 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 really fast at rapid succession. So as to through persistence of vision, you won't notice that it's switching, and that it's only switching one at a time. And if I were to speed things up, a little here. So here, if I speed things up, you'll see it's 57, 58, 59, 60, 61, 62, 63, 64. So it's 00, 65, 00, 66, 00, 67, 00, 68, 00, 69. So if we were to oscillate faster, so that you can't tell that they're off, then you'll see solidly 0, 0, and then let's say 9, 0, 0, 0, 9, 1, 0, 0, 9, 2. And that's how displays work, but much faster and much more powerful. So here I'm using less than 1 milliamp. Each time it rotates through, it's using less than 1 milliamp. If all of them are on 20 milliamps each, so 1, 2, 4, 6, 80 milliamps or so, if all of them were on, solidly lit. But right now I had to switch off all the lights just so that you can see it. Okay, so that's to save power.